Thank you, everyone. My name is Mark Petrucci. I've been with Applied Software now for 7 years, the last 2 years in charge of the Construction Technology Group. With Kevin traveling today, we noticed this morning that the internet was a little bit slow, so I'll be running it here from our Atlanta headquarters. And what we'll do is we'll start out by turning it over to Thad King over at GeoShack so he can talk about the hardware. And then at the end of the presentation, I'll run through 2 demos. I have videos that I've created personally, one dealing with Autodesk Recap and the other one dealing with bringing point clouds into Revit to create as-built modeling. All right, so Thad, I'll go ahead and make you presenter.
Okay. So this is the GLS 2000, and what we're going to do is do an introduction to the laser scanner and kind of go through some workflows. We'll bring up the agenda here. We'll go through some key features on the GLS 2000. This is Topcon's newest laser scanner. Talk a little bit about their precise scan technology and what makes it different from other laser scanners. We'll also go into why we're going to go through the backsite routine. The backsite routine we feel is a major competitive advantage not only for us but for our customers, making it easier for them to manipulate data once they get back to the office. We'll talk about GUI, or the graphical user interface, and the intelligence of that on the scanner. It's a very easy software to use. And we'll go through a typical workflow of setting the scanner up, doing a backsite. You guys will be able to see the screen and the buttons I push, and very easy workflow. Then we're going to come back live and we'll look at a scan and Scan Master and how to register it. And that will lead us into being able to export RCL3 file into Recap or Revit, and that's where the Applied team will take back over and show you how to take all of our software and all of our scans right into the Autodesk products. So first, Topcon wanted to make a scanner that was very versatile, versatile enough to address any of the customers' needs through pretty much any of the markets that they wanted the scanner for. So BIM is one of them, you know, processing power plants, forensic, civil infrastructure. What they really did, we go into the key overviews, is they actually made 3 different models. All the models are identical in how they work and how they look. The difference is the distance they're able to measure. So the 3 models are the GLS 2000S, the M, and the L for short, medium, and long. The short scanner will do up to 130 meters. The medium will do up to 300 meters, and the long goes up to 500 meters. It does have a full dome field view, so when we take off the top handle, which is a very easy, quick thing to do, that handle comes off, and we can get a full directly above us a scan. It is a high-speed time of flight. It's a time of flight scanner first, and we'll talk a little bit about that when we talk about the precise scan technology. And then we'll go through, it has multiple range measurement modes. The other neat feature that it has about it is it's selectable laser. It can be a regular laser that most scanners use, or if you're out in heavy traffic or somewhere where you need an eye-safe laser, you can turn it over to the eye-safe feature and do that right on the same scanner, just with a couple button pushes. The precise scan technology, this is basically a hybrid technology. Before this, scanners were either time of flight or phase-based, which we'll go into in a minute. The GLS 2000 kind of does both. It's a hybrid of both. So not only is it doing time of flight, it's checking the phase on the measurements. It does have a dual built-in cameras, 5 megapixel digital camera. One's a wide angle that is on the side of the machine, and one is coaxial with the lens of the machine. So the telephoto is coaxial, just like a total station. So whatever the lens is looking at, the telephoto camera can see. One of the only units that also have an auto height measurement and be able to backsite to a prism. So the precise scan technology that we talked about, if you look at the screen there, not only are we sending out a time of flight pulse, and if those of you who are not familiar with time of flight, it's sending out a pulse just like a regular total station would, where that pulse goes out, we time it. When it leaves, it reflects off an object, it comes back, and we know the speed of light, and we know time, and then we can measure distance with that. A phase-based laser scanner sends out a sine wave of light. That sine wave is measured when it leaves the scanner. It bounces off its reflective object. When it comes back, the sine wave has shifted, and that shift in the phase is what they call it, is why they call it a phase-based scanner. Phase-based scanners are very accurate up close, and they're very fast. Time-of-flight scanners are much more accurate over longer distances. So the reason Topcon put this as a time-of-flight measurement unit first was that they could get the distance measurements longer than our competitors, and they could also beef it up. So typical time-of-flight units used to be in the 50 to 60,000 range. The GLS 2000 can do up to 120 points per second, and because that phase, that pulse, and doing that direct sampling of the sine wave, we're able to get extremely clean scans, so there's very little cleanup or noise that we have to deal with this scanner. So why are we promoting the backsite feature on this unit? Well, the reason is that it's very easy. No longer do we have to paste targets all over an object or all over buildings, check all the way through. Most BIM job sites and a lot of survey job sites that we run into, most of them have project control. They have control points around. So we're able to put this unit directly over a control point and backsite to a prism just like we would a total station. It does two things. One, it sets the orientation for us, and two, we are able to check that distance between control points and check the accuracy of them before we scan. If there's something wrong, we know it before we sit there and go through a scan and move around. Every time we set up over a control point and backsite another one, we're checking this every time so that we are checking our scans before we get back to the office. This prevents us to have to come back out if we find something in the scan later on in the software that wasn't right. Oh, that wasn't right. We got to go back out and redo that scan. We're taking care of that beforehand, trying to prevent having to go back out to the site. We can prove the accuracy. We can match any layout. So typically on a BIM project, guys that are laying out any of their sleeves or hangers or any part of the project, they're using this project control. So we're matching what they're also setting up over. It does not add that much time in the field, probably a couple minutes per setup, and that couple minutes saves us hours and hours in the office. It eliminates most, if not all, the time of data manipulation. So as we'll show you, and we go through here, when we set up over our control points and backsite and take several different scans, when they bring it to our software called Scan Master, they all line up via control point. And in the Autodesk software, we can have that control point, we can have those control points in the Autodesk software, and so when our full point cloud comes in, there's no manipulation. We don't have to move that point cloud around to know how it's going to fit in the model. It will fit exact the first time with zero manipulation. It's literally a button push, and it's right where it's supposed to be. So to go through our workflow a little bit, we're going to adjust the settings. We actually import a CSV file of points into the unit. We name our station. We backsite to our prism. We check that distance, and then we repeat that process for every setup we have. Once that's all of our scans are done, we go and register them in our Autodesk in our Scan Master software, and then we're able to export those out to Autodesk. So I'm going to go through these pretty quickly, but you can see, my goal is to show you the intelligence of our graphical user interface, or GUI, or our software on board, and show you why we use the backside setup. So this is the main screen that you normally get when you turn on the GLS 2000, and as soon as it warms up, you are going to see what we call the GUI, or the graphical user interface. So at the top in yellow, you can see the station name. That is the setup name of our setup that we are about to do. We have a setup icon, a configure icon, and a data view icon. You also see all the icons down the side, and this is what we call intelligence of having a graphical user interface. Anything on those right-handed bars tells us exactly what our settings are, so that we don't have to go in and check all of our settings every time. To give you an example of that, if we go into the data view here and we go ahead and click on the data view, it shows us all of our scans that we have on our SD card. And how did I know there was an SD card in there? My SD card is bright orange. So I know that my SD card is in the unit and ready to go. So if I wanted to create a new station on that, all I would have to do is click over here into the station. It's going to bring up a keyboard. I can hit the ABC down here for letters. If I'm in letters, that will say 1, 2, 3, and I could hit numbers, and I can just type my station name in. And once I'm ready, I come down here and hit the Enter key. And now my station 2 that I put in there is now changed. If I go to the configure key, the configure key allows me to configure everything in the scanner. So when I click on the configure key, the first thing that's highlighted are my EDM settings, because it's the first thing on the list. It's in yellow. If it's grayed out, it means I would have to click on that bar to make it yellow. So for right now, if I'm in EDM settings and I wanted to set the temperature and pressure, I would hit that key. I would be able to key in my temperature and pressure. I can put it in Celsius. I can put it in Fahrenheit. I can put my pressure in there. Hit OK. If I wanted to set my prism for my backsite, click on my prism. I can put in my prism constant. So if I have a -30 prism or a -7, any prism that any manufacturer makes, if we know the offset, will work, and we can scan with the GLS 2000. Flashlight would be for low light things that would give us some light. When we're done with that, we would hit OK. If we wanted to change something down here, we could come down and I could click on the unit. Everything above it goes gray. The units are now in yellow. And if I wanted to go to like my coordinate system, I could click on my coordinate system, and my coordinates are going to come in as northing, easting, and height. If I'm doing typical BIM, it's going to be easting, northing, height, which is X, Y, Z. And when I'm ready, I just hit OK. And that's the configuration setup there. Now, when I say intelligence of the geographical, or the user interface, is that we have these buttons over here on the side as well. This is our battery button. If our battery is fully charged, I get full orange in there. If I were to click on that, it would tell me how much battery each of my 4 batteries the unit carries. Those are both on the sides. They're the same batteries that we use in our GPS receivers and our robotic total stations. And it would also tell me how much time I would have remaining on that battery. Typical set of batteries, 4 batteries, running scans non-stop. You get about 3.5 to 4 hours for 4 set of batteries. If that was at half rate, you would see a half battery. If it was at getting low, you would see it down at 1/4 of a battery. So this is what I say is intelligence as this change. The same with our next one down here. So you can see here is a different battery setting. That means the battery is almost drained. But down here also tells me if I get orange that I am now okay to level the instrument by using the thumb screws underneath the instrument. If I get this picture right here, the NG, it's not correctable. I'm going to have to adjust my tripod to get it in. I would run out of room on my tangent screws to try to level it. And the third one with the line through it would tell me that the tilt correction's completely turned off. Somebody turned it off. So those will show. So when I select one of these, or if I get one of these on the screen, it's going to tell me that. So if I hit the tilt button, it'll allow me to go ahead and level the instrument. I'm trying to get both big circles in the middle green and these X and Y numbers as low as possible. And then on my SD card, that tells me how many scans at a normal scan rate that I would have available. I can do 7 scans at the scan rate, and I've used 1 gig of my 4 gigs that's in there. I can use up to a 32 gig card in the unit. The SD card slides into the side slot right here. It just pushes in. When you're done, you open the battery door, push it again, and it'll pop out just like most computers. The next one down tells us of our scan area. The scan area tells us right now you see an H, and that means I'm in high speed. If I change this to the detail, it would say D. If I was in low power, it would say L. So when you first turn on the scanner, if someone else has used it before you, or if you used it last time in a mode and maybe you want to change this, as soon as the interface comes up, you know what's on that, you know what mode it's in, and you know the scan area, you know that the SD card's in there, you know how much battery, and you know the next one down would be, here's a picture of our scan area, allows you to change those. And then the next one down is our camera, whether we're going to do the wide angle, the telephoto, or whether the camera's off and we're just getting scan points without pictures. So all these, there's our camera. We can change it from wide to telephoto or resolution high, set that the way we want it, and our home button always takes us home. So anytime we turn on the scanner, anytime we come back to our home screen, these buttons will be active with what we set to them. So therefore, if I know it's on wide, I know I'm in high mode, and that's what I want, I can just go into my scan procedure. I don't have to go in and say, what's my camera at? And check the camera button and say, oh, I'm in wide angle. It tells me with the W right there. So that's what we talk about in an intelligent graphical user interface. So let's go into an actual workflow of this now that we've looked at the graphical user interface. The workflow is going to your setup button. And what we've done is we've just taken our SD card in our computer and we've downloaded a CSV file, simple CSV file, typical in the industry. And what we can do is it's telling us that our station that we selected, that we're going to do an occupy and back site. So we're going to come and click on this button here, and it's going to show us a list of our points and have X, Y, Z's and all of our numbers. We just choose the point we're on, we highlight it in yellow and click OK, and now that point is in our occupied name. We then would be able to come over here to our instrument height, IH, click on this button here, and what that does is takes us into our unit to make sure that we are still level. We want 2 green dots in the big circles, and we want these numbers to be as close to 0 as possible. And then what we can do is come up here and hit the measure button, and it'll actually turn on the camera and point the camera straight down till we can see our point underneath of us, and it will give us a green X. And we would make sure that's right in the center of the dot. I put an example in there that we're not directly on the center of the dot. The other thing is we could come over here where this little gray button is and turn on our laser, and it would show a laser light down so we can make sure we could center right over it. And we hit measure, and it'll take anywhere from 15 seconds to 45 seconds to get that measurement, and it put 1.5 meters in there for us. We're now going to choose our backsite name. Our backsite name is going to do the same thing. We're going to go back to our list of points. We have our prism either on a tripod or a bipod and a pole, and we're going to put that in there. That's point 2 or whatever. In this case, we called it back 1. And then we'd be able to do what's called a backsite scan. So we click on the backsite scan button, and it turns on our wide angle camera. If we wanted to turn on the telephoto camera to see a longer distance, we would come up here and click this, and it would turn on our telephoto camera. The other thing that we could do, again, the regular camera, it's actually on the back side of this, sits right here on the back side, and our other camera is coaxial right here with the lens. So wherever we point that, and we can move the unit and move the lens up and down to make it point directly at the prism. The other thing that we're going to do is make sure it's in prism mode, and you're going to get a little picture of a prism there. And then we can also hit this button here and put a laser dot out on our prism. The scan angle is going to tell us if you're at the center of your prism, you line your crosshairs up and you're at the center of your prism, it's going to go 2 degrees either way to try to scan that prism in. And we also want to give it an HR just like we would with any backsite. So we would hit start, and it would go through. It takes about 1 to 2 minutes, not even, about a minute to a minute 30 to scan a prism. And once that's in, you'll get a little picture that says, okay, you're done. This was a regular 30 millimeter prism that just mapped the outside of the prism. We hit the OK button, and now we are going to have a button that also says backsite checked. So as it scanned that and we hit the check, it actually has measured from our control point to our other control point and will give us the distance in accuracy. So if we were within a 1/4 inch, it will tell us, you were within a 1/4 inch. If you were within an 1/8 of an inch or a 1/16, or if you had it in decimal feet or meters, it will show you all that information. If that information's good, you just hit OK, and we're back to our main screen. And now we just hit Start Scan, and the scan starts. And basically, the scans take anywhere from in high speed to a minute and a half all the way up to extreme detail of, it could be a half an hour scan depending on how detailed you want it to get. It just tells you how fast it's moving. Most of the scans that we do and we train with are in high speed, and we're getting excellent results on it. So now we're going to take those scans, and we would just repeat that procedure over and over. Move the instrument to a control point, backside a different control point, any of the ones that are in our list, scan again. So if I have 7 or 8 scans at the end of it, I'm going to take those back, and I'm going to go ahead and go into Scan Master. So Mark, you want to go ahead and give me the view of Scan Master, or if you can give me the controls.
You still have it.
Okay.
Yep.
So I'm going to go into, going to open one I had in here. So this is one we did at one of our BIM and Beer events. And Mark and his team have another one that we did that we're going to show you. But this was 2 scans, or 3 scans. Sorry, 2 scans. So we set on our control point here. We backsighted to here. We scanned the room. And then we sat on our first control point and did that again. And you can see as I drive into this scan, we actually colored these points from the pictures that we took. So it does take a minute or 2 to take pictures, and it'll take a minute or 2 to scan. You can see the barrels of the kegs that were back there.
Actually, we should mention, Tad, this room was dark. It was very dark. They did not have much lights in this room.
And that's why you see all the purples, because of the darkness. If you want to see, these lights were really the only lights in the room. They were actually deer antlers and moose antlers that they had up here, or elk antlers, I'm sorry, elk and deer antlers combined, and there was just a few lights in the room. So that's why it came in very dark. If we would have lighted the room up. But if I want to change that, I can actually go to my data in here and change the color from my image to, let's say, like a black and white. and it'll go to black and white. I can change that to elevation, and I can put in an elevation range, and it'll change all my points. So you can see on 2 1-minute scans, we got a ton of data. And you will see on the one that the applied team has, we did a room where we were in Missouri, and you can see that. But all we have to do is go over here, and I'm going to make this a little bit larger. When we go into our scan positions, you can see that we had our scans over here on the left-hand side, and what happens is when we go into them, we get our information over here. So all we have to do is match up on ScanMaster is what we did in the field. So we told it we were at backsite, we were backsiting point 2, and the backsite local was our project, and it has our X, Y's, and Z's, and we were within 6,000ths of those when we did our backsite scan. And we just basically tell it we were on point 1, backsiting point 2, and then there's a little scan. When you bring this over, there's a little scan of the prism, that scan I showed you. That's going to be in here, and I just match those up. And once they're matched up, I come over and select my entire point cloud and hit register. And depending on the size of the point cloud, it will take 5 minutes, 10 minutes, 15 minutes. I've had point clouds that were, you know, tens of millions of points that took a half an hour to process, and it's all based on your processor speed. We do have a list of minimums that we require to run ScanMaster, but the nice thing about it is if you have a very fast computer, it will process it even faster. So all we do is tell it on the scan 1, we were backsiting, we were on point 1, backsiting point 2, then we would go to scan 2, tell it we were on point 2, backsiting point 1, and we would go through that with all our scans and hit register, and we're done. We're done with ScanMaster at that point. There are a lot of other things that you can do in ScanMaster, but most people want to register the scan and then hand it over to the guys and then take it over to their Autodesk software. So that's what we're going to do now. I'm going to hand this back to the applied team, and they're going to be able to tell you how they take a scan that we have given them and put it right into the Autodesk software.
All right, great. I'm going to go ahead and share my screen, guys. Screen 2. All right. So I'm going to show you a quick video on Recap and then another one I did with Revit. And I'm going to simply start my Recap. So what is Recap? Autodesk Recap is a free tool. Hold on one second, guys. It is a free tool by Autodesk which allows you to bring in point clouds into AutoCAD, Revit, or Navisworks. Now, you don't need to use Recap, but there's a lot of benefits to using Recap. One, it's free, and so I can make some edits to the point cloud. It's not as powerful as ScanMaster that Thad just showed you. However, you may be getting point clouds from other sources, and they may not be as ready as you need them. So if I bring them into Recap, I could do a little bit of cleanup. In this particular case, all I do is I go and I look for the file that was sent to me, and I can simply drag and drop it into Recap, or I could select the file. Recap recognizes many different file formats, such as Faro, Leica, the Topcon format, E57, very common. So it recognizes a large number of file formats. Now, when you look at a scan file, they're pretty big. When I bring them into Recap, Recap will go through and re-index the file for me, and I can save it as another file format, an RCS file that I could bring inside of AutoCAD, Revit, or Navis, any of my Autodesk products. Also 3D Max and so on. But in this particular case, I've already done that. It'll take a few minutes for it to re-index. When it finishes, then I'll see my point cloud. This is an actual project that Thad and I worked on. We actually did a class out in Missouri, and we did this live when we were out there in Kansas City. This is a room that we were in, and Thad had set up the scanner in the room. And he actually ended up doing 3 different sets of scans. And he did that because you put the scanner in one end of the room, you can't see behind objects. So everything requires line of sight. But the beauty is, because there were control points in the room, all his scans lined up with each other directly. Now, as I rotate this around, this is what I was given from Thad. And there's actually 3 scans in here that have all been unified. Now, one of the things that I want to mention concerning with all of our scans, we have millions of points, and Recap can handle all these points. The free version of Recap cannot join multiple scans. There's a Recap Ultimate can, but I didn't have to do that because that gave me a unified model. Now, you'll notice these points that are kind of outside this room. That's because the scanner had actually shot through the windows, and so it was picking up some of the architecture outside. Well, if I brought that scan directly into Revit, I would get those extra points that I really don't want or I don't need. So I want to reduce this down and focus in on specifically what I need. Now, one of the things I do here, Recap, you have 2 different point of view, isometric and from a camera view, so that it's a little bit easier to work in this isometric view. Perspective was what I was looking for. So what I want you to notice is, notice how the scan had come in and it seems to have been turned. That's just based on the control points that were used in the field. So the first thing I want to do is I have this section box that I could turn it, rotate it, and then I could start pulling the sides in. And when I do that, it's going to start eliminating the points that are outside the box. And so by doing this now, I am actually reducing, and I just eliminated thousands of points that are really not necessary. And so I'll just pull this in real tight. Again, there's no points on the outside, but I just like to get it real tight to my model. That's all I want to see. And if for some reason I just want to see the rest of the model or maybe remove the top, I could drag the top or the bottom down as well. But this is the point cloud. This is what it looks like. And you'll see me here in the video. I'll just pull it down. And there's all the furniture that it picked up in the room. And you can see how realistic it looks. The circles on the floor, that's where the center of the scanner was. And so he had placed it here. There was a point in the back and then another point up here in the front, right behind the desk where I was sitting. And so this scan actually filled in the points that were underneath the scanner when it was sitting back by the entrance. So now this scan, all I need to do is export this out or save this as a RCS file. And the beauty with this is that the file size condenses greatly. It's much, much smaller than the original scan. And it doesn't matter where the scan comes from. The original scans are always large, but with Recap, I can reduce the size of the scans. So when I use them in CAD, use them in Revit or Navisworks, they become very, very small. And here you see me converting this into a unified RCP Recap file. So I'm going to go ahead and finish that up. And now I'll show you what this looks like inside of Revit. So here's a model of the room we were in. And I actually brought his scan in. I brought in Dad's scan, and I traced over the scan with components. Now, using another product called Autodesk Point Layout, I had control points that were in the room, and I placed them in the Revit model. Those control points had coordinates associated with them. I gave Thad a text file that just had 3 lines of text. It had those 3 points and their X, Y, Z coordinates. He put them into a scanner, so now when he set up his scanner in the room, he told it where it was in space. So I'm going to show you what happens when we don't use the scanner that has the ability for us to use the control points. Okay, let me turn this volume down a little bit. So I set up a few different views. Right now we're looking at the 3D view of the room, and I'm going to jump ahead a little bit here. So here's the plan view. These are the control points that I gave to Thad. And there's the coordinates, the easting, the northing, or the X and the Y. So that's the actual values of the points in that room, and that's what I exported to give to Thad. So now what I'm going to do is, Thad had the points, he did the scan. Now I'm going to take that recap file and bring it into Revit, and I want to see how well it lines up with my model. Now when I bring it in, I can bring it in one of three ways, and I'll show you what it looks like when I do center to center. And it just throws it in there, and that's what most people do. They just throw in a point cloud, and they see how well it lines up, and then the next thing they do is they'll go in there and start rotating it. So we can see in this case the scan came in rotated, and even if I go to a southern elevation view, in just a second here you'll see it pop up where the scan is actually not at the correct elevation. And that's just me throwing the scan in without paying attention to the control points that were provided. Or if the scan I received does not have control points, this is what will happen. If I needed this scan for verification purposes, maybe I want to do an analysis to see how flat my floor slab is, then that's not going to help me. It's important that it comes in precisely. So I'll show you another option here. I'll pick origin to origin and see how that works. Well, CAD models, Revit models, they all have an origin. Well, so does the scans. They all have an origin. But when I bring this in, I'm like, where's my scan? Well, it turns out it was actually on a different level, and it was still rotated, but it was much higher. So origin to origin didn't help. But again, what do most people do? They'll rotate it, and they'll move it down to get it lined up with where they want it to be, but it's not as accurate. Now, by the way, I'm running all this on a Surface computer, so there's a little bit of a lag. On my other laptop, it comes in almost instantly. It's very, very fast. So now I'll show you when we bring this in, and we'll use the control points. All right, so I'm going to wait for the video to catch up to me just a little bit. And 1 second here. All right, so I brought the scan in this time using what's called shared coordinates, or using control points. But it's still not coming in the right spot, and that's because I haven't told Revit or CAD or Navisworks. I haven't set up CAD or Revit yet. So I'll show you how we set this up. I'm going to go to my Manage tab. I'm going to select Location, and I'll select Site. And so right now I only have this one coordinate system in the model. What I want to do is I want to set up this model to use the coordinates that I gave to Thad. Jump ahead a little bit. Okay. So right here's the Excel file that has my point numbers with the true X, Y, and Z coordinate. Now if you notice the number for point number 1, the northing says 82, the easting says 98. That is out of the box. But now I'm going to set up my model using APL. I'm going to set up the coordinate system so it matches the Excel file that has the actual coordinates of the 3 points in that room. So I'm going to jump back over into Excel, and point number 1 has XYZ of 100, 110. Those are the coordinates, and I'll paste it. Now I do need to put a comma in between our numbers. And I'll just continue this process with one other point. So I'm going to jump ahead just a little bit here. I'm going to select point number 2. And I just jumped ahead in the video a little bit, and I'm entering the same coordinates as I did for point number 1. Now here's the beauty. If those numbers work, it asks me to give this a name. If they don't work, that means something's wrong at the job site, or something's wrong with the coordinates that they gave me. Now, if there was a problem with the coordinates, Thad would have told me too, because his scanner would have picked up on that too. And what I'm talking about is the space in between the points may not equal what they should be. So it's constantly self-checking it. It's checking itself. So I'll go ahead and give this a new shared coordinate. I'll give this a new name. And jump ahead a little bit. And since I'm going to use this specifically for bringing in a point cloud, that's what I'll call it, 3D point cloud. And now take a look at the coordinates. Remember the coordinates for this particular one was 86 and something else. Well, now it's changed. So I've updated my model to match the coordinate system at the job site, and Thad has those same coordinates programmed into his scanner. So now when I bring it in and I use shared coordinates, that model should line up precisely. Now, just to confirm, I'll go to Manage, I'll go to Location, I'm going to go to Settings, and you can see right there, there's my current coordinate system. So I'll just go ahead and hit Cancel, and I'll insert that point cloud. Now, here's the point cloud, and it came in, and it's aligning with those points on the screen exactly, both in plan and in elevation. I could take a look at a section view, give this a second to catch up to me, and I can now adjust or create my model around the scan. So this is a point cloud, and there's millions of points. I can snap to any one, I can take measurements, or I can use them for tracing, so I can create my objects that I see in the scan. And if we look at it in the 3D view, we can see it here. And I'll just jump ahead real quick here. So that was working with the 3D model. This next section, I want to show you why working with the Topcon scanner and its ability to know where it is in space really benefits if you're going to do something like a analysis. In this example, I have a floor slab, and I want to see how flat that floor slab is. You know, for large warehouses where they have automated equipment that rolls around, there's certain tolerances that they need as far as a floor and how flat it is. So I can do what's called a slab analysis or a cloud analysis. It's the same thing. In this example, I'm going to import this file, which doesn't have millions of points, but it has enough points to demonstrate what will happen. So I'll bring these points in, and they're looking at the control points, and it will know exactly where it is in relation to space. When people bring in a point cloud without controls, they move it manually, and then they have to adjust it vertically. Well, how do you know exactly where how high to lower or raise the point cloud? Well, if you use the GLS where it knows how high it is off the ground and it knows where it is in space based on control, now when I bring it in, I can get a quick analysis of that floor slab and see how flat it is. And so in this case here, my reds could represent highs and my blues could represent lows. and green is anything within range. And that's all configurable. You can change that any which way you need to. All right. So I'm going to go ahead and exit out of here. And let's go ahead and bring up any questions we might have.
All right. Yeah, we do have some questions here. So, and great job, guys, by the way. Let's see. How do I line up scans in Revit if I don't use this scanner?
Okay, so if you don't use the GLS scanner, then you have to do it visually, and you just have to pick an area of the building or whatever you're scanning, and you'll have to go in plan view and just click on it and move it horizontally, vertically, go to an elevation view, and again, just move it until you think it's in the right spot. But literally, there are, thousands and thousands of points, and they're all at different elevations. You're eyeballing it is what you're doing. So you just manually move it.
Very good, very good. Let's see. What's the minimum point resolution you suggest when doing an actual scan?
Thad, do you have comments on that?
It's very difficult to say. That's going to depend on your typical, it's going to depend on your setup. We typically go into, I think it's ½ inch at 32 feet, and that's not your real accuracy of it. That's your point density on that point, or from that distance. If I'm shooting a longer distance, I may want to go a little bit less dense. If I'm shooting a closer distance, I want to, and it really depends on how much detail you want to do. The more dense your scan is, the longer your scan takes. It doesn't matter whose scanner you're using. So, it could go from a couple-minute scan to a 7 or 8 minute scan, all the way up to, if I want to get really dense on it, I could have a ½ hour or 45-minute scan. So it depends on every setup. But typically is that we use, that we're seeing very good results with, is the ½ inch at 32 feet. And I think most of the scanners will allow you to get into some kind of range like that. I know the Topcon, that they have it. It has, I think, 6 different selections that you can use for that. So again, that's a very difficult question to answer, but that's our typical.
Yeah, and just to clarify, and Thad did say it, that ½ inch in 32 feet, that's not talking about the accuracy. We're talking millimeters with accuracy. That ½ inch at 32 feet is, we talk about how many points can fit in that space at 32 feet. So on the Revit side, on the CAD side, it all depends what I'm scanning. And if I'm tracing out walls, I don't need as dense a point cloud. If I'm scanning rebar, and because the rebar is smaller and it's got curves to it, I may need a denser scan. So the answer is it depends.
Gotcha. That's great information, guys. What is the best method of converting the scan to a Revit model?
Okay. So there are products out there that will do some automatic conversion of the point cloud. There's some tools out there that will recognize pipes and structural steel, but the pipes need to be clean. If they're wrapped with insulation, it can't detect. It can't automatically generate the correct pipe size. If the steel is sprayed with fire coating, it won't recognize the steel. So there's some tools out there. Many companies are working on ways to automatically convert scan data to model data, if you will. But it's not. Right now, there's more focus on MEP than architecture. And structural, I should say, MEP and structural.
Excellent. Is Recap required to bring scans into Revit or CAD?
Yeah, I kind of mentioned it, but maybe I wasn't clear on it. So, do you need Recap to bring scans in? The answer is no. However, if you don't use Recap, a couple things happen. Number one, you bring in the entire point cloud, and you don't have the option of filtering out some of the points. Number two, when AutoCAD and Recap bring in a point cloud, they'll go through their own process to index the file. And so you'll be waiting, and it'll take many minutes for it to process the scan so that it's visible on the screen. The beauty with Recap is that it'll convert it to that RCP file that is, gosh, quite a bit smaller. I think it was 80% smaller, maybe more. I was pretty amazed on how much it compressed the scan file size. But when I brought it in, it was nearly instantaneous, as opposed to waiting minutes for it to come into CAD or Revit.
And Martin, just to reiterate, guys, if you don't want to use Recap and you want to get it in, like Mark said, the scans are bigger. Cleanup we can still do in Scan Master as well. So
yeah.
Anything you don't want to export out to, directly in, or even if you don't want to do it in Recap, we have the same routine like Mark showed you. I can make a wall and pull that down and delete all those points off of my scan if Recap isn't the way you'd like to go.
Yeah.
Awesome. Again, great information. Great.
Let me just add something to that, because Thad and I work a lot together, and his expertise is on the hardware side, mine is on the Autodesk software side. But together we've learned a lot about the workflow and the process. And with some of the other demos and training that we've done, the point is, sometimes the scan guys are not the BIM guys, and vice versa. And it's important that there's some dialogue between the field guys and the BIM guys in the office to really understand, what each of you need. And so, with that, when I gave him points, he's like, Mark, I only need the 3 control points. I don't need any other points. So I'm like, okay, great. So I give him what he needs. When he gives me the scan, we show you in Recap to filter it out, but I'd go back to Thad later and say, hey, Thad, next time when you give me a scan, I don't need all these extra points. Can you just clean them up for me and get them out of there? And he'll do that. And so that just kind of shows the importance of, if you have multiple teams working together, it's important that they kind of talk and speak with each other on what they're getting and what they need, so we can kind of, cut out some of the steps that we're currently doing.
And again, to go back, one more thing, the reason we're showing the backsite routine is because it eliminates any guesswork in putting that model and that scan together in the same space. Anything else that you're doing is a best guess.
Yeah, that's exactly what it is. Yeah.
Great points, guys. Great points. Could you use the align command in Revit to adjust the scan to where it, quote unquote, should be?
The align tool won't work because it's a point, so it'll move that point. But if it does move the point, if it does anything, it'll move the point, but it won't rotate the scan. So in that case, I would just use the rotate feature. But you don't need to do that if you're using the control points. So, and I didn't do that at all in my video. I just let the control points rotate it for me automatically. But the answer to the question, the quick answer is no, the align tool won't work.
Okay, great. And last question here, how many scans do you think is appropriate to have an accurate model, or most accurate model, excuse me?